Hello guys, so in this video I'm going to explain the working of Quicksort. So Quicksort is actually a divide and conquer method. So it picks one element as a pivot element and we are just doing the operation, like we are dividing the whole parts. We are just choosing the pivot again, arranging the lower and the left side and higher on the right side. So that is actually how it works. So while choosing the pivot, which is the first question, we can choose pivot as the first element, or we can choose pivot as the last element, or we can choose pivot as any random element, or we can choose the pivot as a median of this whole array as a pivot. So this is actually we can do it as a recursive method also. So consider this array. Okay, so consider this array which is unsorted. So we're going to do the quicksort operation on this. So at first I'm going to take, in this case I'm going to take the last element as the pivot element. So I have taken the last element as a pivot, that is 21, and I'm going to arrange all the elements that is lesser than the pivot to the left side and all the elements that is greater than the pivot to the right side. So here you can see this is the 12 as I have taken pivot. So all the elements lesser than, that is 4, 3, 1, 13, 15, 14, 17, 23 is greater. So till 17 we are just arranging it on the left side, and 13 and 29 we are arranging it on the right side. So now we got two parts. So this left side, again I'm going to do the quicksort, the same operations I'm going to do it. So in this left side I'm going to take the last element, that is 17, as a pivot, and in the right side the last element, that is 29, as a pivot. So this operation continues till it is sorted. So when I'm taking 17 as pivot, I'm just arranging all the lesser to the left side. That means everything is lesser, nothing is greater than that, so it will be as it is. Here also the same thing, like everything is 23 is lesser, nothing greater than that. And now I'm going to do, so this is the next part. Okay, so what I'm going to do is I'm going to take the last element, that is 14, as a pivot. So here it will be 23 as a pivot. So when we are taking the 14th as pivot, so the lesser than 14 are 4, 3, 1 and 13, and greater will be 15. So 15 will come after this. In this case there is nothing lesser, nothing greater, so we can say that this part is completely sorted. Okay, this part is completely sorted. So now we are taking, on the next iteration we are taking 13 as the pivot, and we are just shifting, like 431 is there itself, 14 will be there itself, so nothing changes. And now in the next part it will be 1, so we are taking 1 as a pivot. So 3 is lesser, so it will come on the left side, and 4 is greater, it will come on the right side. So 1, 3, 4, 13, 14, 15. So at last it will be sorted. So we can say that this is one better version of sorting algorithm. We can say quicksort as the fastest sorting algorithm, as it is having a burst time complexity of n square, of course, but the average case complexity will be O of n log n. Okay, so let's see how we can implement it in Python. So suppose this is the array that I have to sort using quicksort. So I'm going to call a function and return the answer here, that is quicksort. I'm going to pass this array into it. So here I'm actually creating the function quicksort. So def quicksort of array. So what I'm going to do here is, first I'm just checking if the length of the array is less than or equal to 1. In that case I'm going to return that same array itself, so there is no need to be sorted. Or else I'm going to take the pivot value. So as I said, in this case I'm going to take the last element as a pivot value. Here you can see 100 is the element, so I'm going to take 100 as a pivot value. So I'm just considering pivot is equal to array of dot pop. Okay, I'm going to remove it actually from there. So array dot pop means I'm just remove this 100, and that 100 is my pivot value. Now I'm going for the process. So I need to, that is the arrays elements lesser than this pivot, as well as greater than the pivot. So lesser I'm going to create once list, and greater I'm going to create one list. Okay, I have created lesser as well as greater as to list. Now I'm going to arrange all the elements lesser than the pivot in the left lesser list, and greater in the greater list. So I'm going to run through this array, and I'm going to check if ei is lesser than pivot, then I'm going to append it into the lesser part. Okay, else I'm going to append it into the greater part, sorry, greater part. Okay, so that is all about doing this. So at last we will be returning the lesser part. That means now look here, after the first iteration it will be like this, no? So we have to do this process again by taking the left part as well as right part. So we are doing this quicksort as a recursion again and again. So I'm just calling this function again on this lesser part, plus that pivot will be the middle value. I'm putting it inside list as it is. Then I'm going to do the quicksort on the right side also this greater part. So this will be called again and again until it is completely sorted, and we will get the answer here. So let's see. 1 2 3 5 7 8 9 10 is sorted. So this is how we can implement quicksort. There are many other ways also, so I hope you understood it. We will see again in next video.